10.4 notes, polar coordinates graphs, page 9. And so last polar curve we're going to look at is the Archimedes spiral. Now this feels a little weird, and a lot of times you will see this written differently. But here we go, R equals theta. The one thing that you do want to remember is here we're talking about theta in radians. And so let's take a look at some of these. Theta r, theta is 0, r is 0. That's pretty straightforward. Theta is pi over 6, r is 0.52, so roughly 1/2. Pi over 4, and you can plug these into the calculator. 0.79, so we'll go 0.8. Pi over 3, we're at 1.05. Pi over 2, 1.57. Let's spread these out a little bit more. 3 pi over 4, 2.36. How big is our graph? Does this one go to 1, 2, 3, 4, 5? So let's keep going. Pi, 3.14. 5 pi over 4, and we're at 3.9. 7 pi over 4. I'm not really sure why I'm picking the pi over 4s. No, let's not do that. Let's go 3 pi over 2. And we're at 4.7. 2 pi, and we're at 6.28 or 6.3. And so as we go to graph these, I got 0, 0. And we're just going to count by ones. Pi over 6 was 0.5. Pi over 4 was 0.8. Pi over 2 was 1.57, 1.6-ish. 3 pi over 4, what do we have? 2.36. 2 right there. Pi is 3.14. 5 pi over 4, 3.9-ish, close to 4. 3 pi over 2, we get 4.7. 2 pi, we're at 6.3. And so basically what we're looking at is as the angle gets bigger, our r gets bigger. And there you go. Down at the bottom of this page, there's a summary of the curves, as well as the equations that give you those curves. You will not be asked to graph on the exam or the final. You will be asked to match with equations, match graphs with equations, and write equations from graphs, just picking out some of the finer points.